let us introduce ourselves. I'm Milind Tambe from University of Southern California.
And I'm Eric Rice, also from the University of Southern California.
And it's really thrilling to see all of you here. I mean, this workshop, we started discussing initial ideas in April, and it's so fantastic to see it really come together. And we really look forward to having a very really wonderful time in the next 1.5 days. But we wanted to give a quick overview of the work that we do at our center. We are co-directors of the Center for AI in Society, and set the stage for the kinds of research that can occur.
Absolutely, and I think I love that we were asked to settle the debate between Musk and Zuckerberg, because I think that our answer to this question is we don't really agree with either one of them. So the idea is not that AI is going to be a panacea, nor is it going to be the end of the world, but rather, can't we use some of these new technologies to work on social problems right now and make a difference in the world right now in measurable, impactful ways? And we think that the future of how to do that is really through these interdisciplinary collaborations that we've started to work through. And so to give you a little bit of a sense of how we orient our thoughts about what is AI for social good, we're thinking about, within social work, there are some grand challenges that are orienting the field of social work. These are problems such as stopping family violence, ending homelessness, issues that are very much social problems that drive a lot of concern domestically in the United States. We're also thinking about the United Nations Sustainable Development Goals as being issues that we're very much concerned with, both in terms of conservation, but also in terms of social impact around poverty and disease around the world. And so what we really want to talk about is our work in this interdisciplinary space is new social science and new computer science. It's not old computer science doing new social science or vice versa, but truly something unique. And the best way to get into those issues really is to allow people to have some depth with you for some time later this morning to talk about particular projects. But Milind and I wanted to provide a little bit of an overview of the sorts of projects that we are working on within our center, and then one little teaser for you as to some new results that we've started to look into, which we think are a great example of the sort of thing that we never would have thought of if it weren't for interacting with one another. So one of our main areas is AI for assisting low-resource communities. A lot of this work in the United States is focused on homeless individuals. There's actually several thousand people that sleep on 58,000 people that sleep on the streets of Los Angeles every night. I realize in this country that is perhaps a small number, but in the United States this is a huge number of individuals. So we've been doing some very interesting algorithmic work looking at peer influence and influence maximization, really trying to move things forward in both the social work and public health space as well as in the computer science space as to how one can think about these problems. We've also started to engage in some work, which you'll get to hear about later today as well, about substance abuse prevention for this population, which also tackles some classic intervention and prevention science problems. And we're also interested in some issues around suicide prevention, although I think we're probably not going to get into having a representation of that today.
So our focus is always on work that goes outside the lab, and we focus on interventions in the field. Another area of work for us is AI for conservation and protecting endangered species. A concrete example of this, the work we're doing with the Wildlife Conservation Society in Uganda, Wildlife Authority in Uganda. The goal is if we can, with machine learning, predict where poachers set snares and get them removed, then we can save animals. And this has actually been, we've been doing this for several months. This has led to removal of snares, protection of elephants and other animals, arrests of poachers. More recently, we've been working with another NGO called Air Shepherd. They fly drones in South Africa, Botswana, and others. And if we can spot poachers automatically in the black and white infrared video that comes in, then we can send in rangers to interdict. So these are the kinds of projects in the AI for conservation space. And I know there's going to be a whole session on conservation a little bit later on today. I also wanted to acknowledge Professor Selman, who's come from Cornell, and he'll be presenting in that session as well. A third area of work at our center is AI for public safety and security. We have a large number of targets to protect and not enough security resources. How do you schedule or plan or allocate limited resources? So we've been appealing to AI techniques in computational game theory by solving massive scale games, providing techniques for scheduling and planning to agencies like the US Federal Air Marshal Service, how to assign air marshals to flights. So they've been using our software for the past 10 years. Same thing for the US Coast Guard, generating patrols in different ports and different police agencies. More recently, this work has been picked up in Israel by our colleagues to generate a way of allocating police to reduce traffic accidents in Singapore, to generate patrols in the ports of Singapore, between the border of Chile and Peru to try to do drug interdiction. So this work will be discussed next week at the GameSec conference in Vienna. If anybody's interested in game theory and security, that's one of the conferences that's up and coming. But if you look at where this work could be applied here, we were here in the Indian National Police Academy last year giving tutorials on these sorts of techniques. And there's a lot of interest in using AI for public safety and security. I was honored to meet with Mr. Vishwas Nangre Patil. Some of you may know, Maharashtra Police is the first to engage with the terrorists on 26/11 in the Taj Hotel. And so we had lots of conversations, and he has lots of ideas on how AI could help. And so these are things that can be actually used here. We haven't, those are things that we wanted to push forward. I wanted to switch tracks here and get into a very specific and concrete project. As Eric mentioned, these are ideas that only come about because of the interaction between AI and social work. So Eric mentioned our work in spreading information about HIV in a social network of homeless youth. Amulya Yadav will speak more about it later today. Now, the general idea how this information spreads is through this independent cascade model. So basic idea is that if one node gets influenced, then there's a 0.4 chance here, for example, that node B gets influenced. This is work that came out of the PhD work of my colleague, David Kempe. And so his point was that this was a reasonable model. He's a theoretician. He used it to prove lots of theorems, and absolutely extremely influential work that's been picked up in the literature. But does influence actually spread by this independent cascade model or other models that have been proposed in the literature? When we implemented these algorithms in the field, yes, they performed really well. And then we go in and actually try to analyze how information actually spreads. What we find in the homeless youth network, that if you have this network, there's a number of people who are isolated, they are not connected to anybody. By the independent cascade model or any other model, they really shouldn't get any information about HIV. But if you look at who gets the information, see that in 3 separate experiments, in one of them, 100% of these isolated nodes got informed, 80% in another one, and about 30% in another one. So this is a surprising result. Why are these people getting informed if information is spreading according to independent cascade model? And in fact, if you look at different models of influence spread, linear threshold model, independent cascade model, their prediction is worse than random in terms of how information spreads. So it's becoming clear that this is not how information actually spreads. And so this is where our collaboration with social work comes in, and they are able to provide some deeper insights.
Right. So part of what I want to explain is that within the context of social science research, the idea of a cascade of influence or a linear threshold, even though we haven't used those are terms developed within the context of computer science, these are ideas that have been kicking around since the 1960s and 1970s as ways of thinking about social process. So we too, when we've been building interventions to capitalize on this social process, assume that influence should spread from node to node in a very predictable fashion. And so this jumping, so to speak, into this isolated space was something that we did not expect as well. So what we have is that we have a dedicated group of these peer leaders that we bring into one another. that we bring in from different social spaces. They meet with one another and my team of folks. And what we found out was that they're not really behaving in the ways that we would expect. What we thought they were going to do was that they would start talking to their closest social contacts about the information which we had given them. But when we actually looked deeply into the data, it didn't appear that that was in fact what was happening. So we started to think about what was happening in the real world that we saw. So what I refer to it as is the Breakfast Club. I don't know if many of you know this movie from the 1980s, but the idea here is that we have the criminal, the athlete, the basket case, the princess, and the brain. So none of these young people knew one another particularly well. They're from different social groups. When they come together in this movie, they let down their guard and become friends for one brief day, and then they go back out into the world and do, their thing. A similar dynamic seems to have happened with these young people that were in our intervention. We were drawing people from different social cliques, and this was by design in the way that the algorithm was constructed. When they came together to work with one another, it seems that there was an activation energy that was generated, that people got excited about this new knowledge that they had. And instead of just going back to their social worlds and only disseminating this information to the people that they already were connected to, it seems that in this social context, they were using this as an excuse to create new social interactions and new social ties. So these were young people that were in a social space where there was a lot of face-to-face recognition of one another, but not a lot of deep interactions going on between one another outside of these small cliques. But this provided an opportunity for people to start engaging in new social interactions around this content. And so when we start to actually look at this, we thought of this, we called it the activation, and I'll hand this to you, Nolan. We started talking about it as what we refer to as the activation jump model. So instead of this being either a linear threshold or a cascading model, what we were thinking was happening was that people were becoming activated to become engaged in social interaction, and that they were feeling free to jump essentially outside of their pre-existing social relationships in order to have these interactions.
And so there is the underlying model. We just didn't want to get into the details of it, but there is an actual precise formulation of this model, and you can see that it is performing much better than the others, and certainly much better than random in terms of area under the curve. So I also wanted to say that in all of these areas, low resource communities, public safety and security, and wildlife conservation, work is only possible because of our partnerships with organizations, NGOs, and others outside. And that's a really critical element of this work to happen. And we're really glad that we have such partnerships possible here and attendees. So for example, for low resource communities, it's homeless shelters and organizations that have been built up on Eric's long-standing relationships, My Friend's Place and Safe Place for Youth in Los Angeles, and hopefully Urban Peak, which will be an organization that Anamika will talk about. For public safety and security, it's with organizations like US TSA, with the US Coast Guard, Los Angeles Sheriff's Department. And for wildlife conservation, it's with the World Wildlife Fund, and as you can see, others as well. So these partnerships are really important in order to make this happen. And of course, here at Microsoft Research, you're very well aware. So that's all actually we had to say. We are, that's our website, and we are committed to partnerships here. We are very interested in building, and the whole goal of this workshop really is to form collaborations and move things forward. So that's all we have to say for today. Thank you.
Thank you.